you wonder what a flying car looks like and how it works? Or are you interested in pursuing a career in STEM but just don't know where to start? Or are you just looking for a meaningful way to spend your dream holiday? Learn from some of the best in the aviation industry as they share their amazing career and the exciting experiences that they have. Explore with innovators and entrepreneurs as they come up with exciting technologies to revolutionize the field. And hear from educators who bring science to life through experiential learning. Aspire Week is here to inspire you. Join us online from 14th to 20th June. See you soon.
Hello, everyone, and welcome to Aspire Week, where we invite speakers to share about their fulfilling careers in the aerospace industry. In this session, we have founder and CEO of Neo Aeronautics, Prof Neo, who will be sharing with us the flying car innovation and the exciting future he sees for the aerial mobility industry. Prof Neo, welcome to the show, and I now leave you to take the stage. Over to you.
Hi, welcome everybody, and I believe that you are having a very good holiday, and of course try to get as much knowledge and maybe some new discoveries along the way. And I'm very happy today to share with you the flying car, and everybody's very excited about flying car. So I will share my slides right now. Okay. Okay, so this is me, and I'm a founder and CEO of Neo Aeronautics. And let's talk about just who am I, right? So I didn't go through the what you call the standard routes in my time, which is go through O level and go through JC and then off to university. And what happened was after O level, I find that actually I love this kind of hands-on using automations, tools, and which I can't find in JC. So I decided to go to the Polytechnic, and there was only two, there's actually one Polytechnic. So Singapore Polytechnic. The other college is called the Ngee Ann Technical College. And I then joined Singapore Polytechnic in the Electronics and Communications diploma. And that is during the time where sort of exposed to flying and joined the junior flying club, now called the Singapore Youth Flying Club, and got my private pilot license. And so I got my flying license before even I get my driving license. And the interesting thing is that I passed my flying license, they call it the FHT, final handling test, one time. It's ultra precision. And I do my driving license test 5 times before I pass. So flying is actually easier than driving. Now, and then I go to universities and off to study engineering, and then I combine both and work in the aerospace sector, electronics, information, communication, and then I went off to teach in the universities. But my passion for flying is still there, and I was like, okay, in the year 2000, I was thinking, where should I combine? When I was in Silicon Valley, working in Silicon Valley, I was like, can I combine both of these passions together, right? Which is flying and engineering. And that's where I was looking at traffic jams in the Silicon Valley itself. In the year 2000, it's really, really packed. I believe now not so packed now, but in the normal times, it's really, really packed, and you get a couple of hours of traffic jam. And so how can I then just simply fly over? And that's where the concept was germinated then, but the technology was not ready. So then, of course, using the drones technology and combining it for urban mobility, and this is where I would like to talk about. Now, feel free to ask any questions, and I will have maybe sort of breaks in between for you to answer some of the questions and what I do. All right, so if you look at the urban current urban mobility forecast, and lots of forecasts about on it, you are seeing that there are many people who are actually sort of working on this area because it's an exciting area, it's an up and coming area, and there are a lot of product launches with different design. Some the propeller at the top, some propeller behind, some have wings, some don't have wings. So each has its own peculiarities in design. I think recent news also shows that, I think last week news shows that like Embraer, they are going to buy a few thousand units to start their so-called air taxi operations. But generally, if you look at the urban air mobility, or we call UAM, so there are market players that you've seen from here. It says EHang Holding, Uber, and Uber tends not to build their craft. Uber is like Uber was doing, right? It's a platform that allows matching of the customers and the vehicles. You have Kitty Hawk Volocopter, which flown in Singapore over the Marina Bay just, I think, 2 years ago. And then we have Lilium, and of course, Airbus working on it. I think Boeing also working on it, right? And Zipline. There's so many. And so if you look at the futures like the Jacksons, right? It's like, okay, I can fly from one place to another, which is literally by myself. That's very, very exciting. So the market actually has a projected growth of about 34%, and it will hit about in 2030, 10 years time, about $6.9 billion US. So I think there are exciting time to work on it. It's not just what you call fly in the pan, and this year craze, tomorrow, next year no more. This is going to be a long-term thing. Will it replace the aircraft? No, you coexist with the aircraft, right? It's just like motorcycles and sport cars and motor cars, they all coexist, but they have a new offering. So which means if we are looking at a career or a business, or to work on this area of drones or human drones, sometimes we call it, there's at least another 20 to 30 years of such possibilities of being employed in the area or exciting time in the area as we go. Just imagine this is like the starting time of the start of the Wright brothers of the aeroplane industry. Okay, so if you have real good interest in this area, you can be assured there's a good career. If you have no interest in this area, I think you should start looking into it and see whether this is exciting or not. Okay. Now, so good thing is based on the facts. The facts is that NASA has done this study on the market in urban air mobility, the UAM market in 2018. There are more news coming out, but and now some of the companies are listed, so you can actually go and view their investor report, annual report, and you can get more data. But let's work on something that is much more authoritative, right, from the government, and it can show that the air taxi market, all right. So the air taxi market, this is for the US numbers. They say that in the US, if the air taxi market has a potential demand of 55,000 daily trips, right now, that's 2018, which means about 80,000 daily passengers. It means it can project a $2.5 billion in the first few years of operations, which is shown here, called weather constraints. Now, weather constraint means you're constrained by the weather. So it's like a perfect or nice weather you can fly. So for example, if raining heavily, you cannot fly. If it's dark, you cannot fly, that kind of thing. So it's weather constraints, right? As a pilot, we always say that this is called VMC, visual meteorological condition. It means you can see and you can fly without sophisticated instruments. But as in aeroplanes, when we go up sophistication and start building more and more features and functionalities in the craft, then it will move from a time of day constraint from daytime to nighttime or night flying, capacity constraints to infrastructure, and then to unconstrained. That means exactly what we're having right now in the aeroplane industry. which is unconstrained, then it's from 2.5 billion to 500 billion annual market size. It's huge, right? And we are only just talking about US alone. Wow, okay, so that tells you that this industry is booming. We are just at the start of the curve. It's a very gentle start. It's not even exponential growth. Very good for career development. Then the question is, well, yes, 2.5 billion, but where is it being used? So NASA basically looks at the emerging mode of transport, right? And where are it going to be? And they define that city center, suburban, and its city. Now, city center in the initial years will be very difficult. It's just like you're flying in, let's say, downtown Marina Bay, Shandon Way, or in Ang Mo Kio. You know, it's just congested, right? With buildings, and city center, high density, definitely is not a good place to start because there's too much regulations. There are just lots of building where you cannot even sort of find a landing spot, right? You got to land on top of the buildings, which is then not as user-friendly, right, for the customer. But if you move on to the edge city, so we move on to the edge city, so it's just surrounding the city center, you can start seeing spots, right? Car parks, a little bit greens, not so high building, and that's where the current model of flying car can actually operate, because you need some, you want to land near the place that you want to go. But of course, if you go to suburban, that's more better, right? Because buildings are like houses, right? And small, maybe 2, 3, maybe maximum 5 stories, and that is low density. So high density, medium density, and low density. So current design is it catering for suburban or low to medium density? There are some people who design for high density, and that needs a lot of regulations to do. But the promise then of urban air mobility is really in a way to decongest road traffic. Now, it depends on the cities, right? So if, for example, in Singapore, you don't have much actually congestion in the road traffic, right? And if you have very good urban infrastructure like your MRT, your subway, then certainly going to the top building, taking a lift down, go to another building, go to the top of the building again, doesn't sound very nice, okay? I'll just take up too much troubles. So I think it's well-planned cities, then it's very useful. For cities that are very traditional in the planning, or they just grow without urban planning in details, then for example, like from Jakarta, you want to move out, then you don't want to move, unless you want to move from building to building within the cities, but generally from outside the city into the city at one specific location. I think those are still possible. Of course, it can improve mobility and reduce transport time, because you don't have a road to turn left and right. You just generally can go a straight path by scheduling. And of course, most of the vehicles right now, or flying cars, are electric driven, so decrease pollution, and I think reduce traffic accidents, and we're talking about road, right? So you still have to figure out how to do it on the so-called in the air. But air, there's law, right? I'm a pilot. We know there's really a lot of laws that you need to understand. But the question then is, when you have a flying car, what's the concept? Is there a driver beside you? That would be very expensive. Is it autonomous? That means when it's automatic, you just take, this is futuristic, right? You just sit in and it bring you to one place. Can be done? Yes, it can be done, but it's the regulations that probably will make life very difficult right now. But maybe in 3 to 4 years' time, it will happen. So if you look at the UAM vehicles, let's take a look, right? This couple of things that are being used. EHang has these vehicles, and it's been there for many years, and they're listed on the NASDAQ. It's China, Guangzhou kind of developed there, and they also developed the transport version. So they were well tested in China. They've been so-called given special permit just to fly a couple of routes, so it's not ready to mass deployment as yet. So this is one design, and you can see that the design used 1, 2, 3 for about 8 to depend on configuration for 4, 6, and 8 of these XLs with double XL. So it's the 2 motors each, which can give it a lot of lift. Okay, And in Japan, you have this SkyDrive. Looks cool. Have 2 or 4, I think mostly 4, 1, 2, 3, and the other side's another 2. The person sitting it, right? So it's called a captivator. Trial, but not commercialized. And then this is Lilium, where you use small little microjets and can turn around, but they're very long wings. Right. So I think the important thing is to understand from the standpoint of view, the science point of view, how do you live, right? No aeroplane, when you fly, the differential in pressure at the top and the bottom allows lift, right? This is called the fluid mechanics. We call it the Bernoulli's theorem. But in here, it tends to use a little bit of Bernoulli's theorem because of wings, but it also use jet, just push it down. Okay. Now Singapore has bought a few of the F-35 jets, right? Fighter jets where you actually use the engine to push the force down, and then it's just leave it. So it's like hovercraft, basically. It uses a lot of power. I think currently all the drones are designed that way, push the wind down, push the air down, and then lift up. It's not very efficient design, but it's the current design, right? But we'll continue to improve it. This is the volocopter. So this different design. You see that they have lots of sometimes even 32s, I think, of these propellers on top of the craft itself, and 2-seater inside here. All right. And I believe we'll have volocopter's representative talking about it. So I will not spend too much time on it. So we have Joby Aviation, and interestingly, you can see it's almost like a plane, except that there's these propellers, we call props, that on the side, and here can turn ups and turns down, so you can go forward. So almost like an aircraft, but it's just like many of such props. It's going to be very expensive or very difficult to maintain. Okay, there's a personal one, which I think is being so-called trialed by the US Air Force, and it's very personal, one person, and then you have sort of wheels here for landing pad, and same as the volocopter, the many props. The good thing about this design is it's quite safe in the sense that the props are up there and the person are contained inside here, but it occupies a lot of space. I can see that round circles or design. All right, so if we compare the couple of units that are available on the market, I mean, available in the sense they are not commercially available. They can't just buy, right? Because they're all still on trial or still under development. And so you can see that there is EHang, volocopter, Joby, and all this stuff. The important thing we want to look at is really how to differentiate. What's the range? And you can see that the range are actually not very far. Constraints now is because of the batteries. The battery is actually very heavy lithium-ion batteries. So then you look at the maximum weight that can carry 100 kilograms to 500 kilograms, and the seating, right? Some of them single craft, small models tend to have one, and it's a pilot. So sometimes you've got to very differentiate it with the law to know whether it's a pilot or operator. I'll explain later. And then you have a pilot and 4 passengers. So when you have more than 2 passengers, then you need a pilot. So basically 2 persons, sorry, 2 persons. So if you have 2 persons in a craft, then the aviation laws basically say one have to be a pilot, means qualified, fully trained, and then 1 is the passenger. So if you look at the max flight time, actually not a lot. We're talking about in terms of minutes, generally not more than an hour. And because of the constraints of the batteries and of course the maximum speed, because this is for urban flying, so you're not going to fly a fighter jet into the around cities, right? So it's not at that speed. So it's probably 100 kilometers, frankly, is very fast already. So we're probably looking at about 60 kilometers per hour, but it's much faster because it's a direct route. All right, so one of the category very important is that whether it can actually be used for under current law, it can be fly. So things like all these categories are unclassified. Means actually the law, there's no law to specify that this is a flying car, right? You either classify helicopter or either classify aeroplanes, which means the certifications is longer. And then there are concept of ultralight, which I will explain later. So you look at the application, intercity, intracity. So that's something that we can talk about later. And that's how you differentiate, right? How to identify craft based on all these features. Okay. So So aircraft with payload of 2 passengers and above are required by FAA to under rigorous airworthiness certification. Now, why I talk about FAA? Because generally, the US standards is the standards that people follow and then modify from there, right? And they also require a pilot license to be operated. That's how you differentiate an identical craft and whether you see that this craft needs a pilot or not. And harder to categorize larger aircraft because of all the FAA regulations. So building a small drone is easy. Building bigger drones, lots of regulation comes in. All right, so therefore, there's a concept of this ultralight aircraft that do not require a pilot license and easier to certify for commercialization, regardless of the design. So I think I'm going to go into deeper to show you how and why such a category is very important if you are starting out to work on one or you're trying to do evaluation. Okay, and curb weight of 115. Just remember 115 kilogram, 100 kilometer per hour. That's basically the 2 dimensions of ultralight. Okay, all right. So if we just take a look at the various craft, and you can see that it can, in terms of money that they pour into it, this is data is based on last year, and most of them have already so-called been listed or being listed through spec kind of listing, which not important to you because of financial instruments. But they have raised a lot of money, so means that it has actually become, people recognize that it will become a mainstream thing. And therefore, as far as your career is concerned, it's very, very good to start working on drones. I believe that a lot of schools are already teaching students how to use drones, right? But how to use versus the design, small drones, and then we got been designs of bigger drones. Just the evolution, right? We are actually moving from the design of small drones to bigger drones. Okay, all right. So maybe I can take some questions first before I go through the rest of my presentation. And I see there are 3 questions, right? Okay, let me just go to the chat room. Okay, so I think let me see. Okay, there are a couple of questions. What's the height allowed for flying UAM? That's the problems. There's no regulations, right? If you fly without putting a human inside, then it's considered as a drone. The drone laws apply. If you're looking at how high, it then depends on which regulations you fall under. All right. So generally for what we call general aviation is 10,000 feet, all right, about 3,000 meters. But I mean, I hardly go up to 3,000, 10,000 feet. I usually, the max I will push is 9,000 feet. Above that, there's a lot of constraints where the commercial aircraft, jetliners start flying. So do you need to go to that high? And because are you an aircraft? What are you serving, right? It's the purpose of what you're serving. Firstly, if you're using a drones and you are lifting up to 10,000 feet, you probably use out the battery halfway, right? There's a lot of forces that the gravities that you have to overcome. Now, some people will say, well, I'll fly at 1,000 feet. Depends. Sometimes you have building heights. Singapore buildings are not that high, but even you go to many cities, only a couple of buildings are very high, right? So maybe a couple of 1,000 feet. But really, if you in an urban setting, right? Let's say we're flying from Changi to Jurong, right? Do you want to fly that high? Not necessarily. Pick up, you're about to come down already. So therefore, you tend to want to operate at a comfortable height. I'll explain what in my design concept what kind of height am I looking at. But the important thing is placements. There's sort of a trade-off between your passengers, operators. Do they want to fly so high to see what, right? It means, if you fly, you want to see the clouds, you can take a plane or take a helicopter, right? But then if you want to see, let's say, the skyline, then you don't want to be that high, right? With 1,000 feet is very, very, very high. Maybe about 100, 200, 300 feet is about there. This required to have a good view. So it depends on what usage you use it for. So do you think there'll be less accidents among the UAMs? That's hard to say, right? If you have 3 or UAM flying, nobody will bother, right? But if you have 1,000 UAM flying in one city, that will be a big issue, right? So remember this type of craft, currently the most you can use is LiDAR. We don't use radar. So collision avoidance are pretty much not in place yet. There will be more software to start regulating in the future. And I see that actually it will take a long time. So therefore, I see, urban aerial mobility is probably at a suburban city, not in the city center, suburban side. I think at least there are a lot more space. But if you follow, let's say in US, right? You have all, PIE, right? So you follow the expressway. That's probably the simplest thing I can know, right? One will be up and one will be down. So in the air, there's still traffic noise, traffic rules and regulation, not just cross anywhere you want. Okay.
Okay, so Prof Neo, I think there's one more question. Maybe you can take one more question before we carry on with the presentation. Then we will leave Q&A for the end.
Yeah, okay.
So one more question being, if air transport being too common or becomes too common, wouldn't there be many accidents, and how do we overcome them?
Actually, if you in Singapore, I think what you're trying to do is, I think NTU or CS actually, or NTU do come out with this kind of traffic regulations, air traffic regulations for low flying craft, right? So high flying craft, no problems, it's all done. So it's a low flying craft. We're talking about low flying craft, right? Anything below 10,000 feet. That is where there will be regulations. Actually, I think the regulations or the command control system for drones, unmanned systems, more or less, I would say there, but tested upon. I'm not sure when it will roll out, but that will probably be the case. I think the regulatory authority will work very hard on this, especially on congested city center. But if it's out like in the US, where you're in the farm or where you're in the countryside, I don't think there's a really big issue. So.
Okay, so it's a regulation issue.
Correct. So it depends on which countries you go to. Okay, so I will now share my screen so that we can go through in details. All right, so this is a sort of important thing here. It impacts how I design my craft, right? So based on the executive summary of the NASA report, right? It basically says that the total market is 500 billion, about probably 10, 20 years down the road. I think not even 10, but 20 years down the road. And therefore, if you have a constraints, you apply constraints. Weather constraints means good weather, we're going to fly, which is worth 2.5 billion. So is it worth it to enter the market now? I think it is, right? Any markets that worth more than $1 billion worth the market, you will get investment. Right. So then, but the issue is that there's a significant legal, regulatory, certification, and of course public perception on noise, on safety, and weather constraints. So therefore, NASA basically said that you really have to address these things through partnerships, FAA partnerships, government industry collaborations, and also legal and regulatory enablers. So what we at Neo Aeronautics, what we really want to do, right? So I'm going to just put it out in strategies, visions, and missions. And one other strategies you look at is existing federal laws and regulations, which is that, do we want to build something that there's no law, or we have to conform to the aircraft law, or aeroplane, which is very expensive, it takes many years to test. So one of the important things that we decided to do is that we should build a craft that will operate within existing law. All right, and so what is the existing laws? And we say that, okay, the FAA Part 103 ultralight regulations. That's where we're going to conform to that, because these regulations exist since the 1970s. And then the next question is, where do we go for? What kind of market, right? Is it an urban market, a helicopter market? So what we are looking at is existing markets. And so if you then look at the NASA recommendation of 2.5 billion existing market, and we have to comply this to Part 103 allow flights operate without pilot license, just usage training. And the other things within the recommendation by NASA is partnership with government and authorities, right? So how do you do that? We also have a sort of social purpose, is to partner with local communities in STEM. So we want people to understand science and mathematics and how you apply it and study it and then use it as a career. So what's our vision, right? So our vision is to build a safe and reliable and affordable. And these words are chosen carefully. Firstly, whatever you do must be safe, especially it's a flying craft, right? Reliable. No, you can fly once, twice, and then after that you need to service it. It's not possible, right? So you got to define how many hours you fly before you start servicing. Okay, and then the interesting things is affordable, right? So safe, reliable, and affordable. How you make sure that everybody has a chance to fly, okay? And for individuals and global communities. And then hopefully we can have build this community instead of just selling craft, right? We're building aerial communities. Hopefully by 2025, we can roll out to 25 cities. Rolling out to 25 cities is not difficult. It's getting the first city, right? The first site to fly. And then after that, there's a modus operandi. You can easily scale up as soon as possible. And our social mission is to interest 100,000 youth in STEM education in every community to operate. So, for example, if we operate in Singapore, we are looking at how to educate or interest people in science and technologies, right? Maybe in drones. So if you look at the existing laws and regulations, you are now looking at the ultralight vehicles, okay? So in US law, ultralight vehicle is used or intended to be used for manned operation. It's very important. Man means somebody must fly it. So what it means is that it cannot be autonomous. It cannot sit there and then it just fly by itself. It must sit there and it must start the engine. There's no engine, by the way. You can start the propellers, right? You press a button and that's a manned operation. Okay, but then it's like almost any other aircraft, right? So when a pilot goes in it, nowadays there's a lot of automation. I can plan the route, I put it into the computer, I start and I put the autopilot. Okay, it's still manned because I can disable it. Fully autonomous means you can't do anything. Somebody or some software will be controlling it. You in the craft cannot do anything. But manned operation means you can engage the autopilot, you can disengage as long as you're fully in control. And by a single occupant. So that's the issue, right? That when you have two seats, then no more 103 so-called applications here. Which means one guy, if a two-seater, then one guy got to be a pilot. Used or intended to use for recreation or sport purpose. Now, I think then this definition of recreation or sport purpose means if you look at it, it's not for commercial usage. That means you cannot pick up passengers and then you charge them. In the aviation law, we have this commercial pilot license, right? Commercial pilot license means you are fetching people to make money, all right? But you're flying into your let's say from your home to let's say your office. That's not considered commercial. Commercial means getting paid passengers. Okay, all right. And then the rest are not that critical, but the red lines are critical. If power weight less than 254 pounds, so this is US, right? They go by pounds, right? 254 pounds NT weight means nobody sitting inside the craft is 254 pounds. It's about 115 kilograms. It's not capable of more than 55 knots, right? So in flying, we use nautical miles per hour, so we call it knots, right? And this is 55 knots. Translated into metric system is 100 kilometer per hour. Okay, so remember this: 115 and 100, 115 kilogram and 100 kilometer per hour. That's very easy. Then if you look at the certification registration, I think one of the important thing is this, and I think that's important here, right? Notwithstanding any other sections pertaining to airman certification. Airman certification is like literally a pilot license. So operators, you see, they never talk about pilot, they talk about operators, okay? Because you don't have a license. Operators of ultralight vehicles are not required, that's very important, not required to meet any aeronautical knowledge. That means don't need to study how engine works. Age, well, can be any age, right? Because they never say it must be more than 18 years old. Or experience, that means no flying experience. Requirements to operate those vehicles or to have airman or medical certificates. So you don't need to see a doctor in order to fly this craft. So what does it mean? It means actually it's quite open. It can apply for everybody, right? As long as responsible companies or responsible aircraft designer will train you up to be a operator. And if you know how to fly drones, you know that half an hour or 15 minutes, you probably know how to fly drones already, right? It's the same. So it's the drone concept. And so this is US law, right? In Singapore law, there's no such thing called ultralight. There's no 103. Okay. All right. So the question is that, hey, has it really been used? And so yes, the FAA Part 103 approved a couple of such machines, and this is the Hoversurf, Russian design flyer. Flyers is now stopped operating, but it's supposed to fly over water, and you can see that it's the landing pad here, the pontons here. And I think one CNN reporter flew it also, so it's over a lake. And then there's this, this is basically a US design, and then it's a Canadian design with spec fly. And it's, you can see on the YouTube videos, so it's interesting, but it's sort of a belly, and the belly has to, you know, you have to move on and then slide and then move up, right? So it's used for grassland. There's in Canada, there's a lot of it. All right, so what kind of models that we're emphasizing in? Of course, it changed quite a bit away. If you go to my YouTube video, you can see that the first version we're looking at is actually what we call the urban mobility model, which is has cover, has a nice seat. But what is really, for us, is just a simple concept design. We test it, we fly it indoor, but this is not the what called the important area that we want to focus right now, because the laws are just going to be difficult. But sports and recreationals are very interesting because in the US, there are a lot of people who are involved in flying, and they are, whether it's hot air balloon, whether it's ultralight or private planes, there are more than 200,000 people in this area. So you can see that S8 SR is the sport and recreation model, are much more sporty, like fierce red Ferrari grills and all this stuff. So it's similar in design, but much more sporty. And and it tends to operate out of the airfield tends to operate out of the so-called urban area, right? It's in a big city. But actually, this is designed based on one. Both designs actually conceptually is designed based on one car park space, so you can take off and land on one car park space, which means in US, if you have a house, you have a garage, or you have a car park in front of you, you can take off and land from there. So you change the concept of the airport, right? When you want to travel, you go to airport. Actually, you don't. So you can move from house to house, concept of house to house rather than airport to airport, and we're in the same mode of transportation. Okay. All right, so we started 2018 the concept technology development. We actually want to do a flight test certification in July 2021, but because of COVID, things get delayed, and the borders are not even opening up for Singapore because we can go to US. But possibly we're doing some testing right now. If any one of you are interested to join our team, volunteers, or just to whatever you call it, internship or whatever, you can always apply. We probably will take in a couple of guys to help out in some of this. Therefore, we hope to actually, this looks like December 2021 is not going to make it, but hopefully by middle of next year, and then we can then commercialize the urban model along the way. So partnership with states, I think, is one of the very important things that we need to do. So we have a partnership agreement of flight trial and certification in Utah. Typically, we're looking at tourist sites, and Utah being not like central LA or New York City is is like urban dense setting is quite spread out, and therefore you can actually test in a suburban area, which is much better. And what you see here is me with Carlos, which is the executive director of the Department of Transportation. And I think he personally said, "This, you should go to this place. This lake, very nice area for people to look around." Right. In 2020 Air Show, and I don't think Air Show is coming back next year, but in 2020 Air Show, we launched our sports and recreation model, but I haven't been able to test it, but it attracts a lot of attention from the then Dr. Bruce Jade of the US Army. And he personally actually wants, and this is Apache, right? He's actually wanted to, personally request that he want to sit inside. But we cannot follow up actually to US because of COVID. And obviously that at that time, the Minister of Education, now and then Transport and now Health, then Ong Ikang also came in to take a look at this. And I think what we're trying to do is really promote STEM education, right? And hopefully contribute to Singapore to the study of science and technology. And this is what I have with the very first craft. This craft has already been dismantled. We have a new craft, which actually in our office. If you want to take a look and visit it when the movement control is less tighter, feel free to contact us, and probably can walk you through in a smaller group. Okay. All right. Some of the engineers are working on the craft at different points in times. All right, and I think that's all I have for everybody. Okay. So now we've got another about 20 minutes for me to answer questions.
Yeah, we have some time for Q&A. So thanks very much for sharing your insights. Let's take a look at some of the questions. The first one being, the Lilium drone seems to be superior in terms of payload, flight time, and flight distance. Do you think it will have the best chance to be the main aerial vehicle in the near future?
Firstly, yeah, Lilium drones in some aspects looks nice. But the first thing that you must look at is that it will be very expensive, right? Because you have all these small little microjets that's flying across instead of one big propeller, right? One big propeller maybe costs you maybe if the motor and the controls maybe cost you $2,000. That small little jets is going to cost you a lot of money. So firstly, it could be very, very expensive. Secondly, remember that these Lilium jets are not organized in a round manner, but they are actually organized like on the what they call on the wing. So what you get? So what you get is that your landing space got to be very big, right? So that is a big aircraft. But you got to look at this. What's the purpose, right? If your purpose is to have tourists and to fly, let's say tourism, let's say Marina Bay South, and then MBS, right? Marina Bay Sands, and from there fly up and do a loop on Marina Bay and land. And then Lilium is not a very sound thing because it's used for a longer distance. So each has its own applications. All right. And I'll say that so whether intercity may be useful, intracity may not be that useful for the Lilium, right?
Okay. Next question. What happens if the battery run low during flight? Are there any measures that can be put in place to prevent such incidents?
Yeah, I think, yeah. So incidents and accidents are different, right? Accidents is that it happens, right? Incidents that something's occur within the systems. Right. The battery run low. So normally when you are designed, you know that it's just like a handphone, right? Your battery run low, you give you a signal. Okay. So there are a couple of things. First thing is whether it's like if you're a pilot, right? It's like I'm a pilot. When I plan my route to fly from Singapore to Malacca, how much fuel I carry. That's the first thing. Second thing, which alternate which alternate airfield is there so that I can land just in case, right? So there's a lot of such things which nowadays can be fully automated on software. So your new plan your route, you will know how much battery is required, and then of course the software integrated whether it's the battery level is there or you need to have more batteries or you need to charge up the batteries. Now also you can mess up, I would say, design the software for various scenarios, such as if the battery somehow fail or whatever, you should find the nearest landing spot to land. And remember, these are not big craft, right? And it doesn't need a runway. You just need to find a clear spot and then just descend. So it can be a controlled descent if the battery level is low. So generally, let's say if the battery has a warning, the software can indicate there's a next best spot, which is like maybe just 10 meters away, there's a clear spot, and then you just go there. You can land on top of a building, right? You can land on the field, you can land in the car park, basically. So I don't think that's the issue. It's a matter of design. Yeah.
Okay. Next. Could you explain urban air mobility?
Could reduce public.
How urban air mobility would reduce public transport network strains or the constraints?
Yeah.
How would UAM reduce the constraints of current public transport networks?
Yeah, I think it will definitely reduce. The question is how do you use it? So for example, in Jakarta, right? So in Jakarta, if it's very congested, or in Bangkok it's very congested, and you need to get out of cities, it's either you get a subway out, or MRT out, or we can actually literally flew out to and not get yourself so-called in the jam. So that's one way, but you have to pay for it. The other thing is, for example, if you consider, let's say, we are talking about human, but you can also look at cargo, right? So for example, let's say you have a cargo plane, which could be FedEx or whatever, and they comes in the airport, which is normally an airport is far away from the city center, and then there are big trucks that bring all the cargoes into the city center and then disperse, right? So these big trucks will cause jams on your road. So the other way is, of course, you have these drones that bring all these cargoes to the city center, and you have maybe your small little bicycles running around distributing. So that actually has impact. Of course, we have to study how much traffic it generated. For human, that's why in Singapore, I do not see much needs for it because literally you have a very good public transport infrastructure. So why do you need it? I don't really see the need. You have taxis, you have buses, you have the MRT, and a lot of people are used to the MRT, and I think the urban designer, transport designer has designed that MRT for most of the population, MRT is just 500 meters away. Why would you want this craft except for maybe the experience, maybe for tourism? Yeah. Tourism. But in other cities, there's a need, right? There's a need, right? So for example, some need to drive to go to the shopping mall, right? But you can actually fly there. So and then quickly can come back. So it all depends. I'll say that it's complementary. We'll find its way along, but for each cities are quite different.
The usage will be different.
Yeah.
I think we have time for another two or three more questions. So this is what is the difference between these flying vehicles and normal helicopters? Because we see that they all have props. They seem very similar. So what is there a difference?
Well, I think the helicopters and the drones are quite different in terms of design, right? So helicopter appears supremely expanded. Firstly, looks dangerous lah. You got big blades and all these things. It is super heavy. Of course, if you fly the Robinson, it's actually not that expensive and heavy. But you have one big blades and the rotors, and then of course the tail rotors, and then do the balance. But it needs space. That's why you have a helicopter pad. And helicopter pad is very big. So it's very difficult to put a helicopter pad on, let's say, Walmart and the parking space, and you sort of say, okay, this parking space is being used for helicopters. It's just difficult, right? But for drones, who are much more designed for low speed then they can take off and from the parking space quite easily. So I'll say that there are different usage, and helicopters, you really need a pilot license, and in US, ultralight doesn't require a pilot license. So the usage are different. Helicopters are used for very, very much heavyweight things, and drones are lesser. And because the technologies right now probably have not been able to reach the capacities of a helicopter. It's just like you have a SUV and then you have a tricycle, the kind of concept. Yeah.
So you say that a flying vehicle will be closer to a car than a helicopter?
Well, a lot of people think that the flying vehicle is going to replace the car. I don't think so. I think this is it's an alternative mode of transport. It's just like you have a car, you have an MRT, or you have a taxi. It's alternative, and then depends on their lifestyles. Some people in Singapore start not owning car anymore because of MRT. Some people say, I have MRT plus share EV. So I think this kind of human drones will be eventually be shared because slightly higher price. You don't need to use it every time, and seriously, to recover the cost, you want it to fly quite regularly. It's just an aeroplane, right? If an aeroplane sitting on the ground, then it's not churning so-called revenue right? So it's very expensive. But if it's constantly flying, then obviously it is going to be cheaper. So I think selling the vehicle probably is only for enthusiasts. But when it eventually come to common usage, it will probably a lot more sharing concept.
Sharing concept. Okay.
Yeah.
Let's take two more questions. Will there be, if flying cars become commonplace, what would protect military bases and airfields from incursions?
Yeah, I think the current concept is that flying cars like drone, you can fly anywhere, anyhow, right? I think even in Singapore law, you cannot fly anywhere, anyhow anymore. So this will be further constraints. I think even before we allow anything to anybody to just go anywhere, it'll be constrained. So in Singapore situation, right, I think even if they really CS is going to allow it to fly, it will be fixed route. That means from one point to another point. And the pilot then, right, I believe the CS will insist on the pilot. So the pilot then will have the responsibility to fly from one point to another point, right? You cannot just anyhow deviate. So this is what we call scheduled bus, right? The bus is fixed route. So during that fixed route, we are quite sure that this is the safe path, right? It will not fly over humans or something to fly over waters or whatever. So I think you will start having that. So once you have that, then there's no possibility of it going to military bases and airfields. But the other way, of course, is what we call the geofencing, right? So it's software, you can actually geofence. That means if you try to exceed a certain zone, then the software can prevent you from actually getting out of the zone. So for example, let's say when I do my private flying, right, on the private crowd, we have zone, right? We cannot exceed a zone and to go to another zone. So I fly. So in Singapore, we fly, let's say, in Bukit Timah Hill, from Bukit Timah Hill, right? From Seletar, you fly to Bukit Timah Hill, then up to Woodland, right? So and in between there are other airfields which you have to conform to the zone, right? To the laws that you cannot get out. If you get out, then you face the problems, right? Maybe your license gone, whatever. But in a drone kind of concept will be pretty much software. I think software in the sense that it fence for you. But if in the US, generally the zone are much bigger, so you can maneuver inside. But again, there are radar to detect. So the issue is always this, right? The issue is that you're flying so low that the radar actually don't detect. All right, so I think geofencing is probably one of the biggest way one of the best way, because when you're flying low, the communication systems are different. Okay, so you can use 5G to communicate, right? So your GPS location get constantly transmitted back, and people will know where you are any one point in time when they're flying low. Well, in fact, not like when you are in a commercial airliner at 20, 30,000 feet, you don't get the handphone signal. Here, you can actually get signal pretty easily. Yeah.
So the regulations will protect these. Okay, due to time constraint, we'll take one more question. And for the rest of the questions, there was actually a list of questions. If you want to address them, you can send them to us on our YouTube channel, and we can address them there. So the last question being, would flying cars follow current civil aviation or GA navigational charts and waypoints, or will there be a need to craft a whole new set of waypoints, air control systems? I think this is a good
question. Okay, so I can't comment on Singapore because the CS regulations, there's, if you are on GA, I mean, GA means general aviation, means private planes. There's already existing laws, just follow it. So I don't think these are human drones pretty much will deviate from there. Probably the regulations will be much different. In the US itself, if we conform to Part 103, that is literally FAA regulations. So you follow current civil aviation, which is very, very, very clear. And then you will look at the classification of the zone, right? Ultralight category, what zone you can be in. If you cannot be near the airport, you cannot near the flight path of aeroplanes when takeoff and landing. So yeah, so those are already there. I think for me, looking at Part 103, I just need to conform to Part 103. But foreseeable future, I would say foreseeable means 3 to 5 years time. It's not like next year. You will start seeing some of these regulations are being tested and being extended. And the test, I think I heard that in LA, they are looking at, in the airport itself, they are really looking at a place for human drones to land. Why? So because just imagine, right? Now you buy air ticket, you buy from LA to Singapore, right? Okay, let's not say LA to Singapore. You buy from Los Angeles to, let's say, Seattle. Okay, look at Seattle, yeah. And so your plane tickets is LA to Seattle. So next time, maybe you can buy a plane ticket called 222, maybe Sacramento Street, LA to 444 Belfer Street, Seattle. So you actually can buy a ticket home to home, house to house, which means a drone will come and pick you up, send it to the LA airport, then you take the plane and you fly towards there to Seattle, and then there, and then you sit in another drone, right? So your tickets may change, right? Yeah, I think there are a lot of new things that we can look forward to if we imagine ourselves what it's going to be. So I think waypoints, all these are standard stuff. If you are into really, let's say, intercity flyings, but if you're into leisure flying, if in US just a zone, I think that's fine. If you're just a what I call ultralight operator, but I think the software will play a bigger picture, because the software can actually do all the waypoints for you. Okay.
I'm sure that will be very exciting, air taxis. So we will end with that last question. Prof Neo, thank you once again for joining us.
Okay, thank you very much.
Our next speaker will be Chandru from Nimbus UAV. And he and his friends are passionate enthusiasts of unmanned aerial vehicles. So find out from them how they actually built their interests into a business using UAV technologies to provide and serve businesses through commercial applications this afternoon at 3:45. Stay tuned. Also, for all the space enthusiasts out there, we have invited a very special guest, NASA astronaut Jeff Williams, on the 1st of July 2021. And he will be sharing with us what it takes for someone to be an astronaut. There is a link to sign up in the chat. And when you end this session, remember to click continue when prompted, sign up and join us then. Thank you all. You have been a great audience. Please give us your inputs on how you found the session so far, and I look forward to seeing you at the next one. Bye-bye.